Hello, I'm George Malin, the Managing Editor of IoT Now, and welcome to today's webinar, the topic of which is Bluetooth and LTE-M and narrowband IoT and wireless synergy for IoT. While there is huge excitement about 5G, this isn't really where the market for IoT is today. Cellular IoT, which is connecting millions of devices across the entire ecosystem, is providing the bandwidth, coverage, and latency that most of the market requires. Cellular technology to suit every app, and importantly, these are mature technologies that are well understood and coverage is widely available, if not quite ubiquitous yet. Apps from smart cities to track and trace aren't waiting for 5G because they're well served by offerings such as Bluetooth Low Energy, LTE-M, and NB-IoT, which meet the performance needs of many of the applications within these and other categories. This isn't to say that these technologies are isolated from 5G. In fact, these technologies will interoperate with 5G networks, and there is an upgrade path for apps that need the attributes of 5G. However, for many, the characteristics of low power consumption, sufficient network capacity, and sustainable cost make IoT business cases both possible and profitable. I'm delighted to welcome today's speakers who bring together the building blocks of IoT, the silicon, the modules, and the modems. From the silicon side, we have Dima Feldman, the Vice President of Product Management and Marketing at Sony Semiconductor IL. From the module side, we have Michael Buonasisi, the Director of Product Management at Sierra Wireless. And finally, from the modem side, we have Jonathan Cave, the Senior Director of Product Management at Laird Connectivity. All the speakers will be staying on after the presentations to take questions from the audience. To participate, simply enter your question in the panel on your screen and I will put it to them. Importantly, please ensure that you enter this question into the question section rather than into the technical chat section on your screen. Now, without further ado, it gives me great pleasure to introduce our first speaker, Dima Feldman. Dima, the floor is yours.
Thank you, George, and it's my pleasure to be here. In this presentation, I will talk about what is cellular IoT and how it's interlinked with the 5G. Maybe just to start where cellular technology started. A long time ago, we had the analog cellular phones. They have been used for voice only. Later, digital GSM phones has been introduced, and we could do voice and some texting. And as technology advanced, we had what was called the 3G technology, which is HCDMA or HSPA phones, where we could browse and have a voice conversation, actually quite nice browsing by time. And about actually a little bit more than 10 years ago, LTE came to the world, and the main message of the LTE was you can do everything over IP. We can do data, voice over IP. And this create really ubiquitous networks where each device could communicate in the same way. And as technology usually advances, what happened, people made more and more capable modems. We started with Cat3, Cat4, Cat6, Cat12, and went to the gigahertz range. But this is not always needed for the M2M IoT devices. And therefore, we and our colleagues from other companies came up with cellular LPWA technology, which started with Cat1 and now is mainly Cat-M and NB, NB1 and NB2. And what is important about this technology, it's targeting IoT space where lower throughputs are needed, but some other benefits are much more important. And I'll talk about them in the next slides. So maybe just to start, how cellular IoT is different from other cellular technologies we know. And when we analyze that, first of all, well, we have to look on the use cases. And for us, cellular IoT often means trackers, smart city, utilities, connecting of our smart home, smart industry, some of the connected house devices. And this is where what we refer to as an LPWA. And if I'm looking on the characteristic of those devices, of course, all of them are low throughput. I also like to call them lazy devices, and for me lazy means most of the time they do nothing till they wake up and transmit and then go to sleep again. And for them, obviously lower power modes are critical. This is what makes those devices to work for 5, 10, or even 20 years for some use cases. And as though they are live unattended in field, nobody is replacing battery, nobody charging them, and they have to last 10 years in field. Good luck doing that with your smartphone. So you can easily see it's a different technology. And the two other aspects are really low cost, low size, small size, and low complexity of the solutions. And this is for us cellular IoT. And as I mentioned, two power modes, I want to briefly mention them before going to the next slide. Those are one of the innovation techniques that came to the world with LPWA technology, power saving mode, or called PSM or EDRX. Those modes are typically not used in our smartphones, but more common in the IoT devices. In a PSM device, what is interesting about this mode, device can transmit data and then to go to sleep for up to 12 days and then transmit again and again without disconnecting from the network, and doing this in a very efficient way. EDRX mode is in a way similar to paging mode in our smartphones, but it is different. In our smartphones, while we are not speaking or using them, they also go into some kind of a sleep mode. But in this mode, they are available to the network, and network can page them every second or 2 seconds. This is not always needed for the IoT devices. And here again, in EDRX mode, devices can go to sleep for longer periods of time, from seconds to tens of minutes. And network will be able to reach the devices, send them a message, and communicate. And those are the two modes that we often use in the battery-operated devices in the IoT space. And I think while we speak about cellular, we all know cellular, it is important to mention why people are using cellular networks for the IoT devices. And I think one of the changes that did happen in the last 3 or 4 years, it became affordable. If before that we have been paying tens of dollars per month for our data plans, now new and more affordable and targeted data plans are available for IoT devices. And depending on power consumption, they can cost as low as 10 cents per month, which is what is needed for the IoT. So it's no longer charges of tens of dollars per month. This is what really opens the market and brings more devices to this market. Second point is a best-in-class security. We do not need to trust proprietary network. We don't need to trust deployments of third party who host those devices. We can rely on cellular carriers, which are known for very good security, and it's a part of the device from day one. The third point is a guaranteed service over time, and we all know how cellular networks are important for our daily life. And in case of natural disaster or electricity outage, somebody takes care about network existence. And if we are deploying IoT service in our factory or in a smart city, the company who will deploy those devices wouldn't typically want to take care of the infrastructure or the base stations. And here again, relying on a public network is a good benefit, as well as the weakest coverage. We today experience in our cities, and actually going out of the cities in most of the cases, we experience very good coverage and no more dead spots or dead spots in the basements. And this is what cellular networks brings to the IoT devices as well. And maybe two other points is one, global reach. The cellular standards today are globally available and aligned. And CAT-M device that Jonathan will speak later on about that can work in UK, North America, in Japan, in Korea, they will work in the same way using very similar networks. And this is, again, advantage of using global technology rather than a proprietary networks. And all this makes those deployments easy. If we just want to deploy a device in the factory, we typically need just to turn it on because the network is there. And this is one of the biggest advantages of using the cellular networks. And before concluding my part, I do want to spend a word about 5G and how it's aligned with the cellular IoT. There is a lot of buzz about 5G. I think this is big hype in the industry today. However, when we are really looking on the standards and the use cases, 5G is not one thing, but it's actually three pillars. One of the main pillars, and this is what we as people outside our work are using, is enhanced mobile broadband, where very high throughput is important, and this is where we use our smartphones, laptop, watches, and more applications. And very often when people speak about 5G, they actually talk about enhanced mobile broadband or very high throughput devices. The other pillar is ultra low latency or high reliability communication. This is where drones and vehicles or devices in the factory can talk to each other in real time. And this is the other pillar, slightly different technology. And the third pillar, and this is where we focus today, is the massive IoT. And for us, the goal is to provide millions of devices per square kilometer or mile, and having slightly more per mile, and actually having a lot of those devices. And for massive IoT, the biggest concern or biggest care about in the network design is how to build network that can support this massive number of devices. And the good news are that Cat-M and NB are already part of 5G. 5G recognizes those technology as a physical layer technology to continue with the 5G networks. And this means that even after the LTE network, or what at some point in time will become a legacy LTE network, will be decommissioned, Cat-M and NB will continue to be part of the 5G. They would be supported through a feature called dynamic spectrum sharing, and this is where 5G base station allocates certain resources in time and frequency domain to our IoT Cat-M and NB devices. It's called dynamic spectrum sharing or DSS feature. And this is what we are planning to use for years to come, for over 10 or 20 years from today, to keep using Cat-M and NB devices in the network. So for me, Cat-M and NB is already a 5G. And after this brief summary of what cellular IoT is, I would like to hand over to Jonathan to discuss how using a socket modem, what are the benefits of using a socket modem from his perspective.
Thank you very much, Dima. So looking at this from a socket modem perspective, and George kind of laid this up right at the beginning in his intro, about the team here on this call come from all of these three layers that you can see here. So top left, you're looking at the silicon from Altair Sony. In the middle, Sierra Wireless coming at this from a module level. And then ultimately where we, Laird Connectivity, come into this is in terms of a socket modem, which is the kind of the middle and the right-hand side images that you can see here. So all of these pieces are required to be integrated into our socket modem to get this full solution. And the benefits of looking at this from each of the different components in this chain all depend on really kind of time to market, the development costs that go with it, with really the socket modem approach that Laird Connectivity is bringing to the table, trying to drive for the fastest time to market with the lowest overall development costs for really that small to medium volume customer who's potentially new to the LTE space, new to cellular, that really needs to get that on-ramp into that technology as quickly as they possibly can. And if you look at that, we're being very clear about the terminology here. We're talking about chipsets, so silicon, modules, and modems. So on the left-hand side of the screen, you'll see in that cellular module bucket, Sierra Wireless is our partner for the module. And then split on the other side, the right-hand side of the screen, we're talking about Laird Connectivity as a modem or a socket modem manufacturer that is integrating a cellular module. So a cellular module, a customer can happily place that down onto the board and go through all of the requirements to integrate a module, whereas the modem integrates the module already onto a host board with additional circuitry, includes things like power management, includes the SIM cards, includes a connector, can include the antennas, and can include a whole load of additional value-added features in terms of certification and software, as we'll talk about in the coming slides. But it's very clear to look at the value proposition here. And when people talk about cellular, modules is the way that the market has gone for many, many years, whereas this socket modem approach is relatively new and looking to drive at particular sections of the market or particular applications, all of which we'll cover throughout this presentation. A couple of those things are a couple of the points in relation to integrating a module versus a modem. So looking at this from left, central, and then right. On the left-hand side, a module perspective. In the center are all of the core tenets or core requirements that any customer integrating cellular will need from a certification standpoint. And then on the right-hand side, what does this all mean from a socket modem or a modem perspective? And quite simply, getting a module such as Sierra Wireless helps you with an awful lot of the pain of integrating cellular into your product. In reality, unless you're extremely high volume and you also have significant pockets in terms of resources in people and in terms of money, doing a chipset cellular design is not on the table for the vast majority of certainly small to medium volume implementations out there in a variety of applications. Most people would be looking at a module perspective, and even then there is some requirements for retesting. You've got to be very careful of how you lay it out. How do you cover for the antenna in your design? How do you cover for the ground plane? How do you keep the best possible performance? All requiring a significant number of people and time and expertise to integrate at the module level. And all of that comes with a cost. Now that cost could be in time, it could come in certification, and it could be in time to market. Because we ourselves, Laird Connectivity, we're a module vendor. We are very much a proponent of modules themselves. But when you walk into the cellular domain in the cellular world, you have to do more than just your usual radio or regulatory certifications for your product. So it's more than just needing FCC, IC, CE, and RED, or whichever country you're looking to achieve. There are also regulatory certifications for the actual network itself. So the concept of this body called the PTCRB for North America, or its European equivalent, GCF, they are all additional testing and certification that you need to have on top of your radio certifications. And then depending on some of the markets and regions that you're going into, you then have a third layer of certifications in the form of the carrier certs. So what do you have to do to get that AT&T certification? What do you have to do for Verizon? Is there additional ones for each of the countries and the carriers that you want to look at? Now, again, moving to the right, from a modem perspective, all of that is in the vast majority taken care of for you. PTCRB, GCF is all done for you. The actual carrier cert, for example, for AT&T is done for you. It has FCC, IC, and RED certification or whatever else is required for that country. Everyone requires post-integration evaluation of a module transmitter, irrespective of whether you're using a module, a modem, or whatever it may be. So that is required, but significantly lessened. And then particularly when you look at certifications, for example, in our modem, we integrate Bluetooth and cellular, and we've already done for you co-located radio certification. So if you have multiple wireless technologies on your board, you also have to test and document and provide certification for the multiple wireless radios you have in that product. And then from a socket modem perspective, we can certify a whole range of pre-certified antennas, both internal and external, again, to layer on some additional elements of value for a customer that's relatively new to the cellular LTE world to make their lives easier. And this final slide just looks at it a little bit deeper from a North American or PTCRB perspective. Similar concept, although we flipped modem on the left-hand side, module on the right-hand side, your same tenets of certification in the middle. But from a PTCRB standpoint, our modem or socket modems as a whole are treated as end products, whereas a module from a PTCRB standpoint is classed as an integrated device. And that makes a big difference in terms of how it can be treated and how it can be tested from both a carrier and from a PTCRB standpoint So for us, very limited certifications is needed for PTCRB. It is all done and dusted for you. You can inherit that into your final product. And then also all of those additional elements we talked about, such as antenna flexibility, additional certs and testing, listing, getting OTA testing done. What about co-location? What about what happens when you've laid out with a different RF path and you've got issues around that? Do you have to retest? All of that is handled for you in this fully finished, complete socket modem approach. There's some of the benefits, and what we'll talk more about combining co-located Bluetooth and cellular in some coming slides. But let's now work with Michael and look at the features and benefits of the core cellular radio that Laird has implemented, the Sierra Wireless HL7800.
Thanks a lot, Jonathan, and thanks to everybody for joining the webinar today. Jonathan did a great job explaining the differences between a cellular module and a socket modem, and the benefits of using a socket modem. I wanted to take a little bit of time to talk a little bit more about the module and some of the features and benefits that enabled Laird to build their device, and also some of the features and benefits that other customers can take advantage of. So I'm going to be talking about specifically the HL7800 module. This was a module that we worked with Sony Semiconductor to bring to market about 3 years ago. So it was the world's first true purpose-built LPWA module from the ground up using a purpose-built chipset. So it's been commercial for a number of years now, and it ships in the millions of units a year now to all these different IoT applications. So like all Sierra Wireless modules, the HL7800 kind of follows 3 fundamental pillars, being simple, scalable, and secure. So on the simple side, we try to have a simple but rich and flexible set of APIs, both at the edge and at the cloud. We make things easy for customers by having options for built-in connectivity with eSIMs on board our modules. And we also have offers that include the cloud side as well, for an end-to-end solution for customers to make things easy. On scalable, the modules, especially the HL7800, it's approved at operators all over the world, global tier 1 operators. So it's able to be deployed all over the world in different countries. And then uses a flexible form factor, which we call CF3, which I'll go into a little more detail later, but it's a flexible and common form factor that allows customers to design once and deploy multiple technologies. And then also just our ability to scale and support customers and get them to market. So Sierra Wireless has been working with customers like Laird, getting them to market for over 25 years. A lot of discussion these days on IoT is around security, and that's a very important part of all of our modules too. So we take a really holistic approach to security, and we work from day one on the design to ensure that security is an important topic and built into the modules. So that includes things like doing security on the modules, doing things like secure boot, pre-provisioning security keys. Because we have the cloud platform and the module hardware, we can do things like pre-provisioning security keys on both the cloud and the edge at the factory to ensure that that secure connection is enabled in the field. We have a dedicated team of security experts in the company as well. Their sole job is just to look at security standards, drive requirements into the team, and ensure that we're following the best practices in the industry. And we also aim to be very transparent and offer risk management and mitigation to all of our devices. So I would talk a little bit about the simple and the APIs. So specifically on the HL7800, there's a lot of rich and flexible options here for customers to interact with the modules. So some customers use the module more as a data pipe and just kind of have their IP stack outside and deal with their data and send it through the module to the cloud. Most of them use the onboard IP stack that's actually inside the module. So the module comes with actually a quite powerful internal IP stack. And especially if you're trying to work on these long battery life applications and being very efficient with your data, using the internal IP stack, which is really designed around being efficient, is the way to go. So when we talk about these types of modules, the API at the module side are AT commands. So these are industry standard way of implementing communication with the module over a serial communication. You interact with the internal IP stack using these commands, and we have a wide variety of options for customers. So we support things like HTTP and HTTPS, TCP, UDP, DTLS, TLS, secure FTP, MQTT. So all of these protocols are built into the module, allowing for host processors to be more simple and offload more of that work to the module. On the cloud side, so we have the modules working with our AirVantage cloud platform. We support a bunch of APIs in here. So these are things like if you want to do device management, we also have a FODA solution. So through cloud APIs, you can manage your fleet of devices using the HL7800 modules, deploy new firmware updates to those modules in the field, check on their health and status, and really keep them up to date over the long lifetime of these modules, and devices are expected to be in the field. I mentioned CF3 form factor before. So this is a picture of the back side, the solder down side of the HL7800 module. So this is what we call our CF3 form factor. So you can see there's a group of ground pins in the middle and then some signal pins around the outside. This form factor we try to keep across our portfolio. So what this allows people to do is, for example, in the HL7800 series, we have HL7800, have the HL7002, which adds support for 2G, and a recently announced HL7845, which adds new band support for Europe on the 450 megahertz bands. All of those use the same form factor. So you can design your product once, solder down individual modules. We also have RC and WP series modules that support Cat1 and Cat4 data links, also using a compatible form factor. So if you have an application that needs to go into both LPWA or higher speeds, single design can work for both. And it also allows for future compatibility. So when there's next generation LPWA module comes out, we would follow the same form factor and allow that easy migration for customers. Talking about security just a little bit. So I talked about having this end-to-end approach. So that really comes with the people and our dedicated team that are part of these standards bodies and actively involved in the industry, driving requirements back into the product teams and making sure that we're following the up-to-date best practices, following international standards, and using trusted server locations, using industry-supplied solutions for secure key management and things like that. We're also a North American company, so we're a Canadian company headquartered in Vancouver in Canada. Very open, follow all the stringent Canadian laws and regulations, which is important for customers to know the kind of company they're working for and the rules that they follow. And then really just partnerships and in-depth working with customers and operators, implementing those best practices, getting feedback from customers, constantly improving the modules on the security side, providing firmware updates that enable security patches for long lifetime products in the field. So going into a couple specific features and examples. So in the beginning, Dima talked about PSM and EDRX modes. And so these are really the new power modes that were enabled with LPWA in the specification. And these are the power modes that are really what are helping customers get these 10 to 20 year lifetimes in the field. Using these, you really need to use these new modes. That's the kind of battery life that you're getting. So PSM is, as Dima explained, is more the mode you use when you just want to be off, and EDRX is the mode where you want to be reachable from the network. So PSM is always the lowest power mode. So HL7800 using the Ultra 1250, it gets under 2 microamps of floor current when you're in PSM mode. So when you're in PSM floor and just sleeping, you're consuming very, very little current. It can run off a very small battery for many years. And then if you need to be reachable, you use EDRX, it's slightly higher, as low as 30 microamps so when you're using this mode. And so we have customers who've actually deployed devices in the field using these modes. For example, gas meters that need to be reachable in case of turning off gas in emergencies. They use EDRX, deployed millions of units in the field on battery power, planned to last longer than 10 years. So very important kind of features of any LPWA module that you should consider if you're selecting a module or a socket modem to make sure you have the power requirements for your application. And then another one to consider is the coverage and the transmit power. So also with the LPWA cellular technologies, we're introduced some of these new power classes that you don't normally see on Cat 1 or Cat 4 or traditional broadband kind of LTE modules. So with LPWA, we've got a new power class of 23 dBm. So this allows for higher transmitting power of the modules. So what that means is that you're getting further coverage and deeper into areas. So you're getting coverage in inside locations, underground, and farther away from the base stations, covering more area, increasing your chances of communicating with the modules even in some challenging locations. There's also an even higher power called 26 dBm. That's more of a specific power that's supported on 450 megahertz bands in Europe and on the HL7845 variant. These are not mandatory features of modules or of LPWA devices, and not all devices support these power classes. So it's an important characteristic to check on if your application needs these types of deep area coverage. You want to make sure that you're selecting devices that have the higher power ability that are standard on the HL7800 modules. And then the last one here is talking about reducing total cost of ownership with Sierra Wireless and Ready to Connect devices. And I mentioned earlier helping customers reduce this with embedded eSIM. So HL7800 and many Sierra Wireless modules come with an embedded eSIM on board, supporting our MVNO connectivity platform. So for customers that want to take advantage of this, it's there. It comes pre-provisioned as an option. Not everyone chooses to use this, and you don't need to. But if customers choose to use it, it's a very good end-to-end solution. Starting with the embedded SIM on the module, activated over the air, supporting networks all over the world. So ensuring you get coverage and connection wherever you are. So that includes our own core network, managing the end-to-end connectivity. And it also means that we can control the security end-to-end, as I mentioned, all the way from the module into the cloud and the connectivity. Giving customers the management platform they need to manage these devices, provision them over the air, change connectivity plans, all of those options can be done through the platform or through APIs. And then also having a 24/7 global NOC, monitoring the health and status of the network worldwide, ensuring the reliability of the network and making sure that the customers get the connectivity that they need. So this can really help customers not have to worry about the logistics and management of procuring SIMs, which network operator they need, negotiating with network operators on an operator basis. So having one provider that can supply both the module hardware right from our factory with the module and the connectivity globally wherever you need to deploy. So with that, I'll pass it back over to Jonathan to continue discussing Bluetooth Low Energy and using that together with LTE-M and NB-IoT.
Thank you, Michael. So the final section of how we bring that original title of this webinar together, which is why Bluetooth Low Energy, so BLE and cellular in combination. What does that do for you in terms of applications, use case, and targets? What is it that Laird Connectivity has developed using both Altair and Sierra Wireless products to get to this product set? Simply put, so Bluetooth and cellular IoT together. If you look at the device market out there for Bluetooth, you're now running into the billions of devices out into the global market in the standard 2.4 ISM band. So widely available globally. Bluetooth has been an incremental or almost a foundation block for a lot of wireless enablement in the general IoT device market that's out there. Since the addition of Bluetooth 4.0 and the Bluetooth Low Energy specifications that came in, extremely low power state for sensors has been enabled by BLE. So true coin cell operation for many years off a standard CR2032. And in terms of Bluetooth on its own or in isolation, you're not looking at any ongoing cost of that connectivity for Bluetooth Low Energy. That there isn't a need for data plans or SIMs. It is a straight up point-to-point or meshed wireless solution in that 2.4 gigs. Yet it's always had a kind of a pinch point in terms of how do you get that device, that Bluetooth enabled sensor or device up to the cloud? How does that data get there? Because it is not IP enabled. So traditionally, Bluetooth has relied on smartphones and tablets and associated mobile apps as the interface to that device. So it becomes the pane of glass on the phone to how you control, configure, send and receive data from a remote BLE device, and then through the phone, then back over cellular or Wi-Fi up to the cloud where that data can be acted upon or ingested into whatever platform. So what do you do when your fleet of BLE devices or sensors that are out there don't have a phone, that they're not part of that ecosystem? How do you get that data to the cloud? Okay, looking at it on a phone may be good for a local connection. You could do service, you could diagnostics of that device by somebody physically walking up into proximity and being able to use the phone and the mobile app to see the data. But what happens if you're a long way from those devices? You want to be able to monitor that from anywhere on the cloud. So a simple, low cost effective architecture for that is by combining both BLE and low power cellular, so LTE-M and NB-IoT, to bridge that data to the cloud, and then enable you to take that action, that insight, to trigger alerts, to do monitoring from wherever you can get access to your dashboarding and analytics platforms. It also overall limits the per device cost and implementation structure for large scale or massive IoT deployments. Not every device needs to have always on connectivity that has got direct IP access to the cloud over cellular. You don't have to have every device with a data plan. You can have a mini network of devices that all report via short range Bluetooth LE to a bridging device that supports Bluetooth and cellular to then aggregate that data up to the cloud. And then you're effectively only relying on a single data plan for all of those remote devices that are out there. Looking at that from our socket modem level, so all of those benefits from a technology standpoint that Dima talked to for LTE-M and NB-IoT via the Altair 1250 chipset is integrated into then the Sierra Wireless HL7800, and that rich feature set that Michael described is then implemented onto Laird's Pinnacle 100 socket modem. It is also included onto there a part from a company called Nordic Semiconductor, the NRF52840. And what that adds into that solution set is Bluetooth Low Energy. And it also adds a Cortex M4 microcontroller, so a full engine of its own, a driver for applications with 1 mega flash, 256K of RAM. We then build around that the SIM card on the flip of this device that you can't see on the back side of this card. There is a physical connector using the M.2 style connector interface on the bottom. And all of the power management is around that, plus then options for multiple different antenna types. So you get all of that richness from Altair, all of the benefits and value from Sierra. You layer on top of that full certifications, and you layer on then the added capabilities of Bluetooth and a full host microcontroller that you can work with for your application development. And that kind of layers a little bit further. So from a Laird connectivity standpoint, on the left-hand side of the screen, you have the socket modem approach, which you then as a customer would integrate into your final end product to be able to leverage the benefits of cellular and Bluetooth and the certifications. Or alternatively, on the right-hand side of that screen, Laird has integrated that into a packaged product, our Centrius MG100 micro gateway, which effectively designs into a standalone gateway product the capabilities from the socket modem, as well as then adding all of the packaging, accessories, cabling, nice simple LEDs, buttons, backup batteries. Anything that you may need is also then layered at either an embedded level via a socket modem or as a packaged product that is ready to go off the shelf, such as our micro gateway, where you'll develop your application and plop that onto the gateway hardware itself. Now, there's several benefits to this. So why add Bluetooth and cellular together? Well, we've mentioned quite a few of those in the kind of the opening slides of this section, but it does avoid the limitations of just a single wireless option. It does allow you to have mesh networks of low power Bluetooth nodes that then route through a gateway or an aggregating device to limit your overall costs. There is a large variety of Bluetooth devices already out there that you'd maybe like to be able to access that data to the cloud, where you can use a device such as this to bridge between them. We take care of all of that co-located certification testing. So all of the Bluetooth testing, all of the LTE-M, NB-IoT is done and dusted for you, all on a single board. And it supports a lot of different use cases and applications we'll talk to in a few points' time. I think the other point I'll touch upon here, this architecture, this solution set of having that Nordic microcontroller with integrated BLE, plus the Sierra Wireless HL7800, allows you to have complete hostless applications. You can run your full application on board that microcontroller core yourself. You don't need a further external microcontroller if you don't require it to drive either the Bluetooth or to drive the Sierra modem. That's all can be done integrated inside of the product itself. And as part of that, we have what's called a full Zephyr RTOS development. So there is a full core RTOS there that you can write your development code, utilize their community, utilize their sample applications, use our own sample applications to really speed your time to market for combined Bluetooth and cellular applications. The other point goes around antennas. So you purchase a cellular module, they generally have a trace pin or a pad off the edge of the board that you would then need to route and specify your RF layout, matching what the vendor provided in order to maintain and keep within the certifications and performance of that module when it was certified. In the socket modem world, we either have UFL connectors on board the device that you can connect to a whole range of external antennas, whether off-board yet still internal, or traditional external dipoles, or we have options with fully integrated cellular and Bluetooth antennas, all on the socket modem board itself. So zero of that complexity, design considerations and layout has to be worried about by you as the end customer. It removes all of that complexity from you and provides you a simple, certified, full range of antenna options already on board the socket modem itself. Now, I tried to touch upon this earlier, and this isn't for everybody. A socket modem fits a particular persona or types of customers, where some of the values that you see on the right-hand side of the screen are important to your use case or your position within your development cycle for your company of integrating cellular generally, or maybe your new voyage into integrating both Bluetooth and the new technologies of LTE-M and NB-IoT into a singular product. So if you're going to run 50, 100,000 units a year, you only need LTE-M NB-IoT. You've got your own host microcontroller in your product. There is, in honest answer, no need for a solution such as ours. You can go to Michael and the Sierra HL7800, lay that down and work it through in your application and go through the design implementation of that. If you're in a much lower volume space, you're in an area where you really want to get to market as quickly as you possibly can. You maybe lack prior cellular expertise or the design of antenna layout and capability and full certification at not just radio level, so not just FCC, IC, or CE that most vendors who've integrated cellular are used to, but all the way up through the carrier and also the network level of certification. The socket modem is a great way to go for you. And particularly if you're looking at a solution set that has both the need for cellular and the connection from that device to remote BLE devices, the Pinnacle 100 is the perfect product for you. And Laird Connectivity, a great vendor with our world-renowned FAE support and the base to really get you into mass production as quickly as you possibly can. There's a couple of application sets here that we've seen have resonated since we launched this Pinnacle 100 and its equivalent sister part, the Centrius MG100. The first is around the connected job site. So over the last couple of years, Laird as a BLE module vendor, we've seen a growing demand or interest for customers integrating Bluetooth Low Energy into handheld tools, into battery packs for those tools, whether that be for the consumer, the commercial, or the professional market. You want to be able to find out where those devices are on the job site. Are they still actually on the job site? Can you get, for example, battery information out of those devices? Do you need to recharge them? Do you want to be able to kind of track and trace those devices on a large scale construction site? So they're implemented with Bluetooth. That's all well and good. That gives you a great local view via your phone or tablet. But again, that point about how you can bridge that local data to the cloud using something like the Pinnacle 100 or MG100 enables you to go from that local view of your devices up to a cloud view, and then whatever dashboarding and locationing you provide on the cloud side to provide management, locationing, and just availability of those devices. So where you can go from that local to the wide area is a great application space in the connected job site for Bluetooth and cellular together. In just a similar manner, very different use case or application though, but a growing interest in remote patient monitoring. Being able to get the key or core visualization of your patient's health after they leave the hospital. There's a wide array of Bluetooth enabled blood pressure monitors, weighing scales, spirometers, all kinds of SpO2 devices, anything to monitor your health can then be bridged via Bluetooth to the gateway to the cloud, to your physician, and then back down to you for any kind of alerting or monitoring. And again, cellular is preferred over a traditional Wi-Fi or even a landline connection, simply because it's solid, reliable, and it will work every time without you having to figure out how you connect this device up to a gateway. It will just plug them in and off the data will flow. And at that point, we've come to the end of this presentation and webinar. So just to ensure we leave enough time for questions, I'll quickly skim through this one. Simple contact us information if you need anything from any of the partners here, as well as then links in this presentation to the Pinnacle 100, the MG100, case studies between ourselves and Sierra, details from Sierra on their module sets, the 78 and 7802 series, and then various information from also Sony and Altair on the 1250 itself. And I think, George, that takes us up to the Q&A section.
It certainly does. Thanks very much, Jonathan, and also Dima and Michael for your presentations. Those were really interesting. We've had a good amount of questions in from the audience, so I'll dive straight into them, just conscious of time. First question I've got is going to be for Dima. The question was, our devices are event-driven, so we don't know how often they'll wake up and transmit. To determine whether it's best to close the modem completely and fire it up when ready to transmit, or use PSM, how much power is required from off, and how much power does PSM per hour demand, please? So Dima, over to you. Sorry, you're on mute, Dima.
Not anymore. Thank you, George. As Michael said, HL7800 module has a sleep current of less than 2 microamp, so it's easy to calculate the energy consumed by the device when it's off. PSM has many advantages of connecting to the network much quicker and lower power coming from the off state. And I really suggest to connect your device vendor to have this discussion in more details.
Okay, great. Thanks, Dima. Let's move on. Another question came in. I'm going to put this one to Michael. The question was, I would like to know if this module offers a way to encrypt or secure the AT commands exchanged with the modem in order to increase the physical security of the device and protect the product against UART sniffers. Michael, over to you.
Yeah, it was an interesting question. So not today. I mean, normally the UART connection between a module and a host device is usually quite physically difficult to get to, right? Because you've soldered down the module, like onto the Pinnacle, for example, soldered down on there. The UART is in the PCB trays. It's usually quite difficult to get access to the UART lines directly. So as far as physical security, it's quite high there. But it's an interesting question and interesting possible future to think about.
Yeah, sure. Interesting. Jonathan, hopefully you've got your breath back so I can direct a question to you. The question is, do I need to get my own PTCRB certification if I'm using the Pinnacle 100?
No, I'd seen in some of the earlier slides, PTCRB is fully certified at the socket modem level for the Pinnacle 100 device.
Super. Let's circle back around to Dima. A question's come in. It says where to place low power Wi-Fi or Wi-Fi 6 in this scheme with more bandwidth and Bluetooth Low Energy and using the same protocols as M1 communication. Sorry, I've skipped a line there. Sorry. The question is using where do you place low power Wi-Fi or Wi-Fi 6 in this scheme with more bandwidth and Bluetooth energy and using the same protocols or standards as M1 communication. Over to you, Dima.
Yeah, it's a complicated question.
Yeah.
So briefly.
Got lost in reading it.
Yeah. I think Wi-Fi and Wi-Fi 6 are much more broadband protocols, and they would be used for different kind of applications in most cases. Also, they would heavily rely on a local infrastructure, and this is where the benefit of CAT-M and NB comes with the game. You don't need to have a local infrastructure. So it's kind of different solution if you would be using cameras, transmitting videos. This is where you want to use Wi-Fi and Wi-Fi 6, while BLE and CAT-M has actually very good match in terms of a bit rate. So it's a nice back-to-back gateway.
Okay, so moving from maybe the higher extreme to the lower extreme, I've got a question here from Michael. The question's a much more easy question for me to read out, which is a relief. And the question is, does Sierra's module support lightweight M2M? Over to you, Michael.
So it does support lightweight M2M, the protocol inside the IP stack. This is primarily used for things like MVNO device management, so it's in device requirements for operators. So Verizon or AT&T, for example, you would use lightweight M2M to manage the device and the connectivity on the module. It's also used in our own device management as a protocol from the device to the cloud. It's not today available as kind of a user configurable client in the module to use for whatever service you want, but we look at those on a case-by-case basis and then determine to add support or not.
Excellent, thank you. Now turning to you, Jonathan, I've got a couple of questions for you. Actually, the first one is, what options do I have for internal or external antennas for use with the Pinnacle 100 that are pre-certified?
So when we developed the Pinnacle 100, we decided to go for two physical formats of the device, kind of at a part number level. One has a fully integrated onboard LTE-M NB-IoT antenna with a PCB trace built into the PCB itself for the 2.4 gigahertz for the BLE. So there is an option of the full socket modem with all of the antennas required included on the device itself. Or there is a second SKU that populates U.FL connectors, so RF connectors, and then we certified with a 5 different antennas. So there's a traditional external multiband dipole that you can utilize with it, so external to the enclosure that you would put the Pinnacle 100 in. Or we have 3 different types of off-board but still internal antennas. So we call these our flex or ReviFlex range that support different cellular bands and also 2.4 gigahertz, so that you would clip those onto the UFL connectors, and then via the pigtail, you would mount that internal off-board antenna to the side, the top, wherever in your closure gives you the best performance. So still external antennas, but just not external to the product.
Okay, and the second question I have for you was, is there a version of the Pinnacle 100 without Bluetooth Low Energy?
It's a good question, and one we've been asked since we took this product to market. Well, fortunately or unfortunately, depending how you take your viewpoint, no, there isn't. And the reason for that is that the Bluetooth Low Energy, in our mind, kind of comes along for free in the architecture that we've laid out of the socket modem. So that Nordic Semiconductor part, the NRF52840, has a Cortex-M4 MCU with all that flash and all that RAM and Bluetooth capability, all as part of the SoC itself. So by getting the microcontroller, you get the Bluetooth comes along for the ride, or vice versa, depending on which way you want to look at it. And then we use that microcontroller core and the Zephyr RTOS that's sitting on there for a whole host of demo applications and source code to drive the Sierra Wireless radio, so you can run it in those hostless applications. So we can't divorce Bluetooth from the microcontroller and a lot of the richness of the feature set of the product, because they all come along in the same device.
Excellent. Thanks, Jonathan. I'm afraid we're out of time, so it only remains to thank our speakers, Dima Feldman from Sony Semiconductor Israel, Michael Bonasisi from Sierra Wireless, and Jonathan Kay from Laird Connectivity. Thanks also to the audience for your attendance and your excellent questions. We look forward to welcoming you to another IoT Now webinar soon. Thanks again, and goodbye.